overview of flexibility analysis using Bentley AutoPIPE Advanced. I always say in all presentation, in all webinars that we dictate regularly, for us, it's really important the title of any presentation. In this case, is only overview. Is only overview of some commands very important in flexibility analysis. But which one? Is regarding exactly advanced version. For us, of course, it's important. First step, divide the importance about our version in AutoPIPE. We have AutoPIPE Basic, AutoPIPE Advanced, AutoPIPE Nuclear, talking a little. And after that, of course, develop a little ideas regarding these commands. Let me share you the screen in comparison sheet. Well, returning overview, flexibility analysis using Bentley AutoPIPE Advanced. As you know, I'm Carlos Rincon. I'm professor of engineering virtuosity. In general, my expertise is more directed to mining and oil and gas. I have around 12 years like lecturer in this kind of solution. Agenda today is first talking about a little the version that we have in AutoPIPE. AutoPIPE Standard or AutoPIPE Basic. Comparison with AutoPIPE Advanced. Second, buried pipe analysis. Third one, response spectrum assignment. 4, fluid transient. 5, wave and buoyancy. 6, interoperability, open plan isometrics. And 7, support optimizer. Talking all, the third point, response spectrum, honestly, is included in AutoPIPE Basic and AutoPIPE Standard. But we consider that this subject sometimes we not add in all content. So we want to remark in this presentation like addendum. So in general terms, when we're talking buried pipe, fluid transient, wave, buoyancy, interoperability, open plan isometric, support optimizer is AutoPIPE Advanced, but response spectrum assignment is an addendum from AutoPIPE Basic. You want to say something, Wendy? You hear me very well? Can you hear me? I want to check if the connection is good or now, please.
Yeah, we can hear you.
We can hear you.
Perfect. Okay, first step, AutoPIPE Standard against AutoPIPE Advanced. We have, well, this is video structure, okay? But regarding that, we have a data sheet, of course, that we can share to you. We have 3 versions, mostly in the first sheet. Similarly, when we are talking about the 3 versions, but the principal difference starts in soil structure interaction. When we in AutoPIPE Advanced, we have the capability to do, not in the standard. Other stuff important is seismic anchor movement, stress isometric, time history, and buoyancy. So this is the main difference between basic and standard. Other difference important, the number of loads. I will put pause. The number of loads. The loads in basic version usually is 5, okay, by default. But in AutoPIPE Advanced, we have more cases. Talking about thermal, temperature, or user cases. So when you are using AutoPIPE Basic version, You have the limitation of 5, but of course, if you are comfortable with that, doesn't matter. But if you need more, you need to do a separate file that you can work perfectly, but it's a separate. And when you, for instance, you need more than 5 cases, giving importance to work with AutoPIPE Advanced. I will share the data sheet a little. This is the data sheet. Of course, we can share to you. Data sheet is a comparison chart. As I told before, the number of cases and these commands that we were talking about before, fluid transient, buried pipe, and so on. Okay, continue. So, in a representation in the software, where we can see the main difference. For example, if we are, this is an example, right? If we are an AutoPIPE, this is the scope of today. It's not exactly to do graphically nothing, but remember in our contents, in our webinars, you can model here modeling. Imagine for a while that you have something like that. You have an structure, you have bulbs, okay? You have bulb here, you have line, you have anchors, supports, and so on. You can see the difference between both when you are in loads. In loads, mostly, you are defining the difference between AutoPIPE Advanced and Basic. With AutoPIPE Basic, you can do many stuff. You can do all modeling. You can do vessels, not for calculation, but for modeling. You can do structures and supports. And what kind of loads? You can do a static earthquake. You can do wind. That is important in many type of project. But the commands in AutoPIPE Advanced start with buoyancy, that we will talk later about that. Buoyancy, wave, of course. We have fluid transient, and we have soil in all these commands. So this is the main difference. You are in any system defining something, calculating something. So when you want to use that earthquake, that's it, and you can use AutoPIPE Basic and wind and snow. And in response spectrum, you can do by basic. But when you want buoyancy, wave, soil, fluid transient, interoperability with isometric, you need AutoPIPE Advanced. Well, we return a little. So first part of the content, analysis buried pipes. In buried pipes, we need to remark that these commands are recognized by American Society of Civil Engineers, okay? With the addition of the automatic soil calculator according to the latest ACES standard. So what happens when you are modeling buried pipes? In general terms, it's the same stuff. You are modeling the line. What you do in AutoPIPE, you define a profile, okay? You define a profile, and you put a name in the profile. This profile could be the whatever you want, okay? Clay, sand, mixed, what you consider. And you define the spacing. When you define the spacing, this software recognizes a kind of springs around or along the line. That means you are adding a rigidity in along the pipe, okay? That is very important because it's so different to have a model without soil and with soil. Of course, sounds logical. But imagine a line that we defined before, like this, okay, is in the air, suspended. So if we put soil, we have many springs supporting the line, okay? And that's the main idea of buried pipe. How it works a little, okay? This is an example already, but regarding that, the important here is, okay, I have a model, and I have a part buried, okay, that has interaction with soil. Imagine for a while that this part, yellow, or orange yellow, mostly, is the buried pipe, the part in contact with soil. And this part is not exactly contact. In fact, if you see, we have a kind of support here. Imagine this is suspended and the rest is buried. So the model, you can model everything you need, of course, okay? And when you are defining this, you need to define a soil property, okay? The soil property, you can modify or create and insert or modify, but works, a soil identifier. So identifier could have the name you consider. It's a name, okay? I can put Carlos if I want, okay? In this case, it's a PIP or something like that, horizontal. Sometimes I put clay, sometimes I put 60 inches pipe with clay, depends, it's a name. So you go to this is the most important part. You go to insert or modify but, and you create a profile. The good part is when you select, for example, 16 inches, okay? Imagine for a while, I have a 60-inch pipe. When you select 60 inches, the software will recognize 60 inches by default and put automatically mostly data similarly. For example, this H is a standard distance for buried pipe 60 inches. This is automatic. Of course, you can edit if you consider that it's not 72, it's 80 or 100, what you consider. But the software recognize, okay? The software recognize by default some parameters, and you can declare, no, I disagree with this friction angle. I will put different or other coefficient or similarly, okay? After that, the software determines stiffness and springs depend of the stiffness that you consider, low, high, or average, okay? Usually I consider low because it's more conservative. But of course, depending on case, if you consider that your soil is so strong or a little average and you don't need to be so conservative, you can select, okay? So this is the main purpose of that. After that, the software recognizes the soil spacing and you can do the analysis. If you compare, I did many times, you can remove the soil or put the soil and you will see amazing difference. People asking many times to me, if I don't have AutoPIPE Advanced, I can model something buried with soil interaction. Well, not directly, but it's not impossible. Let me show you something, okay? This example, if I'm very well, is this, okay? This is already the example. I have in soil identifier the profile, okay? The profile that I showed before, okay? But if you don't have AutoPIPE Advanced, you maybe can declare many nodes here and put a support, okay? So what kind of support? What do you consider, okay? Maybe a stop or a spring, maybe a spring is more logical, but be a stop is not impossible. So if you put many supports and maybe supports in all directions, because the soil is a all direction restriction, okay? When you have a buried pipe, you have all direction restriction. You need to declare something like a spring or something like be a stop with no gap. What means no gap? Well, will be, well, be a stop is no gap up and down, but you can declare a guide no gap, and this can is the restriction everywhere, okay? I will delete because of course it's not the scope. And this is the example already. The next part, remember the agenda, the first buried pipe. The second one, response spectrum. Response spectrum, remember, is included in basis AutoPIPE or AutoPIPE standard. But always we want to share important information that maybe we not mark in all the contents. Imagine for a while, we have response spectrum. What is response spectrum? We will not spend much time with the detail of this important part of the dynamic analysis, but just to put in context, okay, it's a graphical representation, okay, it's a graphical representation, will be actual or probabilistic, okay, depends. You have a standard AC, IBC, you have in Eurocode, you have in many parts of the world probabilistic by the sum. In Trinidad, for example, you have a probabilistic curve response spectrum, okay? Or you have an actual curve for time history, depends, right? But talking only about response spectrum, you calculate usually by spreadsheet or by APP or by software, and is relating these variables, okay? This is differential equation about response dynamic analysis, I mean, not response spectrum. The mass is did by the software, of course. The damping related to the spectrum and the stiffness that is calculated by the software. Finally, you have the fourth, okay? How to do inside AutoPIPE? You will go to response spectrum and create a new, and you can put your values. Imagine, now I have a spreadsheet, perfect. I put one by one, and you can see the curve. But if you want to do more automatic, you go to IBC and see how it works, and change the parameters. Of course, if you are in the United States, you can only change the zip code and that's it, okay? Imagine I live in Miami or I live in Los Angeles. I change the zip code and that's it. But if you are in Trinidad or Barbados or other parts that allow this code, you change the short period and short second period, okay? Basically, the software recognizes very well. So, in general terms, this other example, already imagine that it's already, you go to response spectrum, and you can check the spectrum already or the spectrum that you can create. The name that you can consider is the frequency, for example, acceleration, displacement, whatever you consider, okay? Or if I have the same, for example, this is the same already example, I want to declare a new one. The new one is Trinidad, okay? The newest Trinidad and IVC, I can edit this value, okay? This is the main idea of this part. The software will recognize this when you have the combinations and the analysis. In which part? Well, in modal analysis, recognize response spectrum. In modal and response. And the static part in a static sec, okay? I will return with the third part, fluid transient. Talking about fluid transient, carry fluids like water or similarly, okay? This effect of the line in the pipeline, okay, like a flow damage, and many scenarios relating that. But it's important, as you know, as you consider, talking about stresses in the pipe. So for these, AutoPIPE recognize a fluid like external data, and you can introduce what is the scope and what is not scope. The scope including fluid loads, but AutoPIPE not included checking of hydraulic loads. That means it's not hydraulic calculation, it's more stresses calculation by fluid. That is different. In the part of the hydraulic calculation, we have open flow line. My colleague Julio Isao, together with Wendy and the team, of course, can share to you many information about that. But regarding AutoPIPE, mostly fluid transient is a stress calculation by fluids, okay? So, in general, the application can be used to analyze a single pipeline. And the assumptions, generals, depends of many scenarios that you are considering. Of course, fluid density, fluid velocity, and speed of some is sum of 10, and I will show in a few. This is an extract of the window that we open in the fluid transient button, okay? The process implies definition of these parameters that include general data, name of the flow that you put by your criteria, density, fluid type, sections, and speed, okay? So you are defining a model, okay? You go to loads, remember this is only AutoPIPE Advanced, and in fluid transient you put a name like this, okay? The name is the W1, for example, okay? And this is external data you need to calculate externally, okay? And you choose the type of fluids and the flow rate in points. Which point? Well, depend on your model. My model, for example, have points A00, A04, C00, and you are considering points. This is very important because you can define only zones. No, I want only the C segment. Remember, for a while, I will show my screen, my model. Remember, when you are selection, you have segments. So you have C segment, okay? Or you have A segment, okay? And so on. Depending on the segment, you can declare the same time of soil. You can declare one segment only for fluid transient, okay? That is so important because, of course, depend of the definition that you are considering. After that, the software will recognize this external data for calculation. And this is only for stresses. An example of results including these results, and of course that you can check. Remember, I will remark something. Of course, this is an overview, an important overview, but if you have a question with many details, of course, you can email to us to look or to develop or to deep more about these commands important. So after when I will finish, of course, I will annotate something to complete ideas and share to you with through Wendy, through Benka. But this the important here in fluid transit, you define the load, okay, and you can define the load in dynamic analysis because it's more dynamic. Remember, in AutoPIPE, we have, in analysis, we have several types. We have dynamic, okay, and we have static, and we have model, okay? In dynamic analysis, we can define dynamic external of many types, and in static, we have a static that can be wind, gravity, temperature, and so on. But regarding fluid, the software usually recognizes like dynamic, and you can declare with the name that you define before, okay? So an example can be a combination of a static and dynamic, or you can separate if you consider the important is the name and the sign, okay? The fourth part today is buoyancy. Remember, buoyancy is in general simple calculation, I mean, or I consider, right? But wave is other important that together is not exactly the same, of course, are different, but are related in some stuff. So both part in one chapter we were talking about. Buoyancy have this behavior. So a pipe in the water, of course, okay, have a weight, and these have a behavior that sometimes you have an uplift, okay? Give me a second. You have a lift, you have a lifting, for example, here. Basically, I remember when I was my first years designing, I did with the spreadsheet. It's not so different, not so difficult, right? You have a weight of the pipe, you have a kilogram per meter, the density of the water, and so on. And you are calculating if you have lifting or now. Maybe it's not so difficult, but if you have a more complex model, of course, it's really important to have this command in addition. And you consider a partial buoyancy or complete buoyancy depends on the system that you have, okay? So I have a line many kilometers, for example, or and a part is buoyancy or not, okay? And you can put, you can edit properties. No, I can I want to put a cover or a additional wage or whatever you consider that in addition put more weight to the pipe, and this is so normal depending on the project. So you go to load, you go to environment, you go to buoyancy, and you define the command, and basically is easy. So you go to buoyancy part in loads, and appears this kind of window. The four data that you are considering mostly is the water surface elevation, logical, the gravity of the water, the CA, and wind exposure factor. But I think that these two first is the most important. And you can define partially or completely. Regarding waves, we are not talking about buoyancy more, okay? Regarding waves, you go to loads, environment, and waves command. But in theory, you can develop more or can research more. But we have different types of waves. Three are most important that we have in AutoPIPE is area, Stokes, and flow function. So this is a kind of representation important to have to you. Remember that this content will be posted in our network, in our platforms, and you can check every time you want. But in general terms, that this is the area, Stokes, centralized and solitary wave that we have in AutoPIPE. The importance of this is mostly to be more consistent, like the actual wave that we have in a specific zone, and put in AutoPIPE regarding, of course, the pipeline. Okay. So when you are in AutoPIPE, what happened? You go to loads, and you go to wave. Okay. In the wave part, you declare name. Remember, similarly, that we did in soil, in fluid transient, and so on, you can declare a type of wave, wave 1, wave 2, okay? The type, Stokes, one type that we talked before. The load case, we recommend relate to a user case. What is a user case? I will declare a pause, okay? For a while, a moment. For example, user case, okay? When you are defining a load, you have, remember, you have thermal pressure, okay? You have thermal, usually, by default, you have gravity, thermal pressure, and you can declare earthquake, okay? Seismic anchor movement, but talking about user is an external load. Could be any load you consider. For example, an additional weight and concentrate force. No, Carlos, I want to put a force 100 kilograms. Why? Because I consider that we have 100 kilograms, and this you related to a user. Okay. User case is, remember, is an external case that you have no name, and it's important to declare for some reason. How many you have in AutoPIPE Advanced? Remember, user case in AutoPIPE Basic 5, in AutoPIPE Advanced 140. So that is important with user case. It's not only for waves, okay? But in the case of wave, returning, you need to relate to user to declare an external user case. So the final, you will have pressure, temperature, gravity, and waves. Wave will be user. Okay, maybe earthquake you can define by earthquake, but user case is the most common representation of these external type cases. So other parameter, of course, wave type, we talk a little, okay? Density, wave height, you know, is too common to extract from a survey, right? But we do our best to extract from a survey, a research company that have a really good survey, and try to put up data. And if we don't have extract from other research important in the region or so on. Okay, this is the example. This is an example that we are considering wave and buoyancy. Buoyancy, okay, 4 parameters. That's it. Okay, elevation, gravity. Gravity is usually 1, but you can edit 1.1, 1.01, and you declare buoyancy. That's it. Okay. You can see in show the water level, and the software recognizes to you, no, we have here a declaration about the water sea, okay, in show. So you define loads and you declare there. In wave, you go to loads and declare waves in the same input data. You can show in hydrodynamic data partially or completely depend on your example. Okay, so it's important, the definition and after the graphical show. Okay, we are the agenda 5 part. I think this is the 6th, I think. Just to check a little to be sure, right? In the agenda. Okay, 6 and 7. Perfect. Six, interoperability, open plan isometrics without AutoPIPE. This is one of my favorites. I mean, why? Because, as you know, when we work multidisciplinary projects, we have mechanical engineers, civil engineers, structural engineers, process engineers, you know, people disconnect, depending on the interoperability, we are more connected. But in my experience years before, I remember I was working with a team. I was doing a design by software, and I have a completely department with 2, 3, or 4 people doing the isometrics. And it's important job, I need to say. But regularly, depending on the quantity of isometric, the quantity, you can spend 1, 2, 3 days doing 60 checks, or depending on the isometric that you have. Okay, but in open plan isometric, that external APP that you are connected without a pipe, you go to file isometric and you connect your calculation with isometric. So what is the main idea? AutoPIPE allows the option of split automatic and allow to you configure general nomenclature, and you can edit after if you consider. No matter if you have a simple stuff like this or complex with many lines everywhere. The important here is you start with a already pipeline. You go to File, you go to the file, and after you need to analyze before and save isometric. The isometric, this is the most important part. I will do a pause here. You need to save in a specific address, of course, but you say to the software, automatic split or no. So you will have one isometric or many isometric in one click. You are saving huge time in only one step. So before you need to, of course, you need to save and analyze, and you repeat this procedure. What happened when you go to save isometric? Well, basically, you click OK, and the software print a kind of window like this. This isometric is very complete, but it's more focused in a stress isometric, okay? When you see this window, the open plan will open and appears already. And you can do in one step or in a split. In a split, you have many windows at the same time. In this case, maybe not completely necessary because it's a simple, but it's a really useful with nomenclature, with the principal box, with the data. You can do several times as you want automatically, and you can edit. You can edit what you need before and after, depending on the cases. I have cases, for example, that I have more complex stuff, and I have this line, and all of these. You go to File and save the isometric and open the open plan isometric. The same idea with different purpose. Okay. Finally, support optimizer. Support optimizer, the second part of today. Support optimizer is a prelocator that pretends save time to you, because of course we know criteria that is relating to spacing. Okay, for this type of diameter we have spacing, for the other we have spacing, but the support optimizer do iterations to you. Okay, and the interaction to you is focused to provide several solutions to maybe have less support that you are considering in your mind. Okay, this extract that I will share, because it's the last part of today, we are showing in Spanish and English because we will share in our network, okay, with subtitles, like the important step. We will do comments during the representation, okay? Talking about AutoPIPE Advanced, the commands correspond optimizer. And what is the steps? You go to support optimization up, okay? To these purple circles, okay? This is a prelocators. You put in reasonable places, and you go to assign only to include in each calculation in locator group inside the support optimization group. Okay. After you go run analysis, the first locator group, the second run analysis, and after the most important, optimization. Optimization, you go to optimization options, and you can declare different criteria, but including the criteria are design criteria and optimizer option. In optimizer option, this is related with machine capacity, okay, or machine capability, and you can align with all the criteria shown, okay. You can select the priority, normal or high, and you can select hanger if you consider, okay. Finally, you go to submit job and consistency before you consider. When you put submit, this is a optimization. What happened here? I did in 1 second, but honestly, not during 1 second, during more. Depend of your machine, can during 10 minutes, 20 minutes, 30 minutes, or more, depends. The software do this, well, in this example, the example is 5 minutes, okay? And show 1, 2, 3, 4, 5, 6, around 10 cases, 10 examples already that you have different supports, okay, located. Because the circle purpose is a pre-locator. After, you will have a locator final, okay? In my case, I will show something. I will finalize this idea. But the software show the solution and with the spacement and the cost, okay? The cost related, the ratio, and so on. Because all these are criteria related what we are doing. When you choose each option, you will select and choose any solutions. The solution have 3, 4 supports and not 7 and 10, okay? And we have different options to find optimization. My recommend is to choose that we are most related to your criteria, preferred criteria, okay? I will show something. I have, for example, okay, I have already, okay, this case I did minutes before, and I spent 15 minutes. Each example have shown the information that we shared before. Exactly, a cost referential that depends on the support that you are considering and the ratio and the name of the example, okay? If we click any solution, the software will open and show to you one solution, only one, okay? Let me show. This is only one. It's not all these purple circles. It is 1, 2, 3, and 4. Of course, it's up to you to maintain or change. You can return, try. No, I prefer the second one to check and repeat the process depending on the case, okay? Maybe sometimes we put by criteria. No, I consider that by criteria, I need 8 support, but the software are doing to you a recommendation based in the stress and based in the properties and based in the data that we have. What kind of data? Well, this data. Remember, we have gravity, thermal pressure, and earthquake. Depends. Okay. So based on this and based on the displacement, the software say, no, I prefer 1, 2, 3, 4 support, and that's it. Are different scenarios to share to you the best recommendation as possible. Maybe in this line is a little simple. I need to be honest. But when you have a more complex, imagine, I don't know, imagine these or with many lines or this we line parallel, depending on scenario, you have dots to declare the supports with consent, right? Because of course you tell the software, right, each 5 meter, but this recommendation is really better to you when the project is more complex and other kind. So with this idea, we will show one more time to the record, okay?
Hi, Carlos. We're not hearing you.
Because I'm showing this only to the record, okay? It's finishing.
Okay.
Don't worry, just a few seconds more. Finally, the idea that we were sharing. You can see the recommended options, okay? The recommended option that you are defining before, okay? Remember that you have optimized the solution and help AutoPIPE that you have the example and the steps. No scope, seismic anchor, we will develop in other content, and no scope, for example, other type of analysis. Regarding licensing types, really important, remember that we have in Bentley 2 types, perpetual and annual license, okay? Wendy can share to you better to the team what is the difference at the advantage. But in general terms, perpetual more recommend for long time projects, and annual more recommend for short periods, okay? Remember that we have a Learn server. For all our clients, you go to Learn server and you have content inside, okay? You go to AutoPIPE or any software, no matter. If you have AutoPIPE, you can learn by from regarding STAT or other software. And after you have a certification like this, okay? We have an important program that is called Accredited AutoPIPE Basic User or Advanced User. Me, for example, Carlos, an accredited AutoPIPE user. I did the program. It's an exam, okay? It's a test. You communicate with our specialist, and he sent to you 2 or 3 or examples and a little test that you need to send by email with explanations. They respond to you, it's okay or no, if you need to do improvement. And after you have accreditation that you could add to LinkedIn, for example, or any platform. This is an extract of our new Virtuosity annual license. For Q&A, we recommend today, for the time and many reasons, you email to Wendy. You have my email, carlos.rincon, carlos.rincon@bentley, but I prefer to Wendy. You can email any doubt that you have, of course. And remember that all this presentation will be recorded and put and post. Will be recorded and post in our platform, social network, and LinkedIn, YouTube, and different platforms that we have. In summary, remember that AutoPIPE is a software for flexibility analysis related to the multidisciplinary projects. One of the most important capabilities is the interoperability. It's one of the software in Bentley that have more capability in our company. Have the capability to connect with the Stat Pro and the capability to import files, CSAR, PDS, PDMS, and so on. You can define structures, you can see the behavior of the structure, not design the structure, but the behavior, yes. And you have many codes important, very known in the world. Have really important commands like interoperability with OpenPlan, like solid structure interaction, like connect with the Stat Pro. You export, for example, the load to a Stat Pro. You have Stat Pro, and Stat Pro receive the loads in one step, in 1 second. We have solid structure interaction, and we have the buried pipe and other kind of commands important, including only in AutoPIPE Advanced. For that, AutoPIPE is one of the better options on the market for this kind of project. I want to say thank you. Of course, I will receive questions by email by Wendy. So taking account 2 or 3 important ideas, okay? AutoPIPE, of course, is easy. It's easy to the modeling part. But the regular analysis, basic, okay? AutoPIPE basic. And advanced, I always say that, but I highly recommend AutoPIPE Advanced when you have buried pipes or buoyancy or fluid transient or open plane isometry, okay? These 4 commands is important to define if you need AutoPIPE Advanced. And when Support Optimizer is not completely necessary, but it's a really good tool, complementary to your project. So with these ideas, please take in account to your decision. And if you will do something like AutoPIPE, but you are with dubs to use basic or advanced, it's not big deal. You can do by basic, but with consideration and support. However, I recommend highly AutoPIPE Advanced for these cases also. So Wendy, thank you again. And thank you all assistants today.
Thank you, everyone. You all can feel free to reach out to Carlos or myself with any questions, or if you would like us to do a one-on-one with you, Rydell, we will schedule with you. So you can email me.
Yes,
And
yes, I am. Of
Yeah.
course, I will be glad to help
Yeah,
as
and-
possible to any that needs a little more technical information or commercial and technical. Okay.
yes, so you all feel free to reach out to us if you want to get some more information, and it's not a problem.
Perfect. Remember, this record session will be posted soon, in a few. Okay.
Okay, so one more chance. Anybody else have any questions? Okay, thank you very much for joining us. I will also send the recordings to each one of you who were in the session. Yeah. Okay. Carlos, thank you very much.
Thanks to you,
Bye.
Wendy. Thanks to all. Bye.